Okay, wonderful. So we'll let folks join as they can. For now, let's go ahead and get started. My name is David Murphy, Marketing Programs Manager with BayWa RE, and this is an exciting webinar, and more importantly, opportunity for us at BayWa RE Solar Systems as we're looking to make the transition into Title 24 a lot easier and profitable for our current solar installer partners, as well as you home builders here in California. For this webinar, we have two presenters. First is Jonah Liebes, who will give an introduction to the BayWa RE Home Builders program. And a quick little history about Jonah. He's a C46 contractor in Southern California and has so far managed over 6,000 successful residential solar installations. After 15 years on the contracting side of the industry, Jonah is now using his experience to help other contractors comply with California's energy code and get solar installed on every new home built in the state. We also have Brian Selby, who is a certified Energy Analyst and Title 24 expert. And Brian will summarize the requirements for building indoor air quality, solar PV systems, and an all-electric pathway for compliance. Before we dive into the content, though, a couple quick housekeeping items. We've scheduled 60 minutes for this webinar, and that does include time for Q&A. If you joined any of our other webinars, again, we absolutely encourage questions. Please enter your questions as you have them in the questions window. We're going to save those for the end of the material and go through all the questions at once. In your window, you'll also see a chat feature. Please do not use this. We're going to focus exclusively on that Q&A feature for this webinar. This webinar is being recorded, and you'll receive a link to the recording once we've wrapped up. That said, the Q&A at the end often has a lot of really valuable content, so you want to stick around for that today. Okay, and with that, Jonah, I will turn things over to you.
Great, thank you, David. Yeah, hi folks, my name is Jonah Liebes. I'm Director of Home Builder Services for BayWa RE Solar Systems, and appreciate the introduction, David. Indeed, I've done a lot of solar in California over the last 15 years, and I really appreciate you joining this webinar. It's hopefully going to be the first in a series about our Home Builder Solutions program, and specifically the new California solar requirements. Our goal for this program, and especially with this webinar, is to illustrate how to best comply with the requirements and take advantage of them to grow your business, whether you're a home builder or a solar contractor. We're developing the program to encourage Title 24 adoption and creating what I think of as an ecosystem of sorts where manufacturers, builders, and solar contractors work together to implement solar projects. If you're a home builder, in addition to supplying some of our top-tier solar products like LG, Enphase, Unirac, and the rest of our lineup, we provide access to our installer network and special home builder pricing and fulfillment structures. If you're a solar contractor, as part of the installer network, you can team up with BayWa on new construction projects, giving you advantages like supply consistency, flow of projects, and what I hope we can do a lot of is co-proposal opportunities where your solar company and BayWa work together to win home builder solar project opportunities. For the webinar, though, and for today, I thought it was really important that we all, myself included, get a really thorough understanding of the solar requirements and get exposed to some of the nuanced ways to comply with the California Energy Code. You know, there's some tough requirements, or they can be tough if you don't understand how to deal with them, and that's why I'm super happy that we got Brian Selby, and who you'll hear from next, to teach us about some of the intricacies of the Title 24 requirements. So with that, I'm happy to turn it over to Brian, and have at it, Brian.
Great. Thank you, Jonah. And David, I appreciate the opportunity to come share with your group here. Today, I'm here to share on behalf of the WISE program, and I'll get into the WISE program in just a minute and tell you a little about what we're doing there. But I'm an energy consultant. I've been doing this since, gosh, the mid-1980s. I did not set out to be an energy consultant. I kind of fell into this out of necessity of our local building department enforcing our Title 24 Part 6 Energy Code. Back then, things were really simple. I stuck with it over the years, became a certified energy analyst through Quebec. I currently now developed the exam for becoming a CEA as part of my role here. I'm also a HERS rater, although I don't practice anymore. I've done many solar verifications for the new Solar Home Partnership. But today what I want to do is talk about where we're headed with the 2019 Residential Energy Code. Some of you may have heard things that may be alarming or may be things that are a great opportunity for builders. What I want to do is kind of give you an overview, dispel some myths or some things that you may have heard or may have believed about it, or possibly validate some of those. So let's dive in here and give you a little bit about what the WISE program is all about. The WISE program stands for Workforce Instructions for Standards and Efficiencies. This is a program that was developed by the California Energy Commission, managed through the California Home Building Foundation and Consol, which is an energy consulting firm, to promote installation of high-performance attics and high-performance wall requirements. Those were introduced in the 2013 standards as measures, but really came into full effect under the 2016 standards. So when I say standards, I'm talking about the Energy Code or Title 24 Part 6. So if there's any terminology or anything I share during my presentation that you're not familiar with, please put a question over there in that question pod, and I'm happy to explain it later. But this is funded through the California Energy Commission. It is sunsetting this year, so probably wrap up the end of or the middle of next year sometime. Basically get people up to speed on those requirements. The scope also includes training and teaching the industry about other measures that the Energy Code is requiring. So they do that through classroom training, on-site instruction. They have a lot of reference material in their wisewarehouse.org website. This includes detailed case studies and information about high-performance walls and attics, how to install them, how to frame walls, how to do all this stuff. Other insulation documentation from manufacturers, like how to install their products, live training videos, and then a wealth of reference material. You're welcome to go there. So I want to talk about a little bit what's new in the residential portion of Title 24 Part 6 or Energy Code here in California that will go into effect January 1 of 2020. Currently, we're under the 2016 Energy Code, which will go through the end of this year. Now, this is subject to all projects that would trigger the Energy Code when your plans are submitted on or after January 1, 2020. You'll be subject to the new code. Otherwise, anything submitted before that date will still be subject to the 2016 standards. So one of the hot topics with the changes to the 2019 Energy Code is obviously increased building energy efficiency. Through research and studies over all 16 climate zones, this is expected to reduce energy usage by approximately 7%. That's not a big number. This applies to all low-rise residential buildings, so multifamily, 3 stories and less, as well as all single-family, duplexes, townhomes, anything that fits into that low-rise residential category. So these increased efficiency requirements make the attic and wall insulation requirements a little more stringent than are currently required at this point. One thing of particular interest that I think is that everyone must know is quality insulation installation, or QII, will be prescriptively required. When I say prescriptively required, that means that if you want to comply with the Energy Code prescriptively, you have to do that. If you use the performance approach, you have the option to trade that off. Unfortunately, there's such a large value or time-dependent energy valuation for QII that it's going to be really difficult, in some cases almost impossible, to trade off the amount of energy associated with that value of QII to not do it. So that said, be particularly aware of that measure. It comes with some very strict timing considerations of getting a HERS radar out there to inspect air sealing, inspect insulation installation. It could take several visits for that HERS radar to verify all that. So if it's missed and you've already drywalled those walls in, then unfortunately it's too late. There's no mitigation for QII. You'll have to find something else to offset that. And I'll talk about a measure a little bit later in my discussion that might be a possible solution if that's missed, or if you want to trade that away. So obviously we have more efficient windows and door requirements. There are other measures that affect mechanical systems. We have new HERS measures that are triggered depending on the type of mechanical system you install. In addition to the building envelope measures, we have some increased indoor air quality requirements. So these requirements, obviously are based on providing a more healthy environment. They filter out particles, allergens, other things that might be bad or harmful for our indoor environment, and providing more fresh air from the outside to dilute any of those indoor contaminants. So what this means is increased mechanical ventilation airflow to the measure of about almost double what's currently required for mechanical ventilation or outdoor air under the 2016 Energy Code will be required under the 2019 Energy Code. In addition to that, any air conveying device that has a duct more than 10 feet long will be required to provide at least a 2-inch MERV 13 filter, or through a calculation and increased surface area or size of that filter, you could go to a 1-inch MERV 13 filter, but that's just an option. In addition to that, there's HVI, or certified range hoods, means the HERS radar needs to certify that range hood that's designed for local exhaust meets the minimum requirements for sound and for airflow. So you can go to the Energy Commission's website, download this infographic to the left. It kind of covers some of the details or highlights of what the 2019 Energy Code offers for low-rise residential buildings. They're claiming that there's about $19,000 worth of savings, and that's comes at a cost of about, I think, $8,500 initial cost. So obviously our Energy Code is designed to provide cost-effective energy efficiency, and now we're going to be talking about PV or power generation requirements to make our houses more energy efficient, make the grid more harmonious, and save our occupants money. In addition to those measures, and what I'm going to focus on through the rest of this presentation are the solar PV and flexibility requirements. I've seen a couple questions come up that I would have almost bet I would have seen those questions come up, and hopefully I'll be able to answer those now. If not, we'll carry these off into our Q&A session at the end. But the PV and flexibility requirements apply to all new construction, and what they're designed to do is offset the electric energy usage of that particular dwelling based on the regulated loads. It's not designed to offset all of the electricity, but a portion of that electricity that deals with heating, cooling, lighting, and some generic plug loads. So that goes into the sizing requirements here. It also encourages self-utilization of that electricity that's generated through these PV panels. When I say self-utilization, I'm talking about utilizing that energy that's generated during daylight hours through the PV system and storing that into a battery, or in some cases, storing that into pre-cooling a house before the sun goes down, using that energy that you have when it's abundant and utilizing that energy later in the afternoon when the sun goes down. So some of these terms really have a lot of meaning. So you'll hear that used a lot: self-utilization, grid harmonization. We'll get into those details. So these requirements include solar PV. I'm going to talk about it specifically. I know there's a question about whether this is mandatory or prescriptively required. We'll cover that in detail. There is an option for a community-based solar, meaning that you wouldn't be required to put the solar on a rooftop. You could put it in a ground mount system that serves the entire subdivision or multiple subdivisions, as long as that community-based solar option is dedicated to that particular set of dwellings. There are some very strict regulations on providing community-based solar options. All has to be pre-approved by the Energy Commission before going into operation, but you can check that out through the Energy Commission's website if you're interested in something like that. In addition to that, there are battery storage options. Now, battery storage is not required. It's a performance-only trade-off. You could use that to reduce the size of your solar system or other things that I'm going to go into a lot more detail about. Now, a lot of people have commented to me about an all-electric pathway for compliance. Under our current code, there is an option for all-electric, but it is dependent upon whether natural gas is available on site. If it is available on site, then there isn't an option. You're penalized for going all electric. With the 2019 Energy Code, they removed that penalty, and it's no longer dependent upon whether natural gas is available. It's the only dependency is which option does the builder, homeowner, occupant want to choose for water heating. Water heating was the key change in the 2019 code. We've had space heating as a electric baseline for at least one code cycle. So we'll get into a little bit more detail on that towards the end of my presentation here. So what does the 2019 Energy Code accomplish? We've seen a lot of goals set. We've seen our big, bold strategies for energy efficiency. We've seen our million home solar rooftop. We've seen all these things. We've even seen a goal of zero net energy by 2020. Well, guess what? Our 2019 code is our 2020 energy code. And the focus was on cost-effective energy efficiency measures. That's always been the foundation of our energy code. It's got to be cost-effective. We can't drive people out of purchasing a new home or building a home based on the extreme measures. Now, that's debatable. We won't get into that today, but just understand that in order for measures to go into code, they've got to be cost effective. Now, it also encourages renewable energy sources, meaning most common are PV or photovoltaic electric generation. So that's been what we've experienced from 2008 when the Big Bold strategy went into effect through our 2016 code cycle. Where we're headed, or what our energy code is also trying to accomplish, is meeting the needs of our energy grid. You might think of the grid as the power distribution throughout the state. There's certain times of the year when there's a huge demand on our grid, and the common solution would be, oh, just generate more power. Well, it's not always a great thing. So what this code does is encourage grid harmonization, utilizing that power in a better way so that we don't overflow that grid or cause any amount of imbalance in that grid, at least as much as possible. In addition to that is reducing carbon emissions. So that's why they switched to an all-electric pathway as an option. We're going to see future code, 2022 code, which I'm already working on now with case authors, really focuses in on carbon emissions, reducing that fossil fuel gas emissions, and relying more on our own generation. Now, I wanted to show you a glimpse of what a project looks like that complies with the 2019 Energy Code. So this particular case study is a little over 2,300 square foot, two-story home, 17% glazing, 4 bedrooms. This is a master plan approach, meaning that this project complied in all 4 cardinal orientations. So it was determined that the east facing, so the front was facing the east, was the worst case scenario to get this to comply. So this came from Consult's production builder database. They did have to kind of level the playing field and ignore some of the minor costs like the R5 doors or some of the HERS testing just to make it a level playing field. So that kind of sets the stage for the base compliance case study. So on the left, you'll see measures that it took to comply under the 2016 Energy Code. Now, these aren't prescriptive requirements. These are design choices that the builder wanted to demonstrate compliance with. On the right side, you're going to see the changes that were necessary to get that project to comply under the 2019 Energy Code. Now, these are specific to Climate Zone 12. If you're familiar with our climate zones, great, you'll know that Climate Zone 12 is a hot climate zone. This is Stockton, California, Central Valley, goes from Sacramento down to about Merced, Madera area. So you can see they kept the 2x4 walls. They just had to increase the cavity insulation slightly, increase the continuous insulation slightly. In addition to that, the attic insulation went from a R13 below roof deck. That means there's insulation at the roof deck and insulation at the ceiling. They increased that from R13 to R19. They included a whole house fan. They went with the prescriptive performance values for windows. The heating cooling system was a wash, no change there. Water heater was a wash, no change there, but they did add a 3.1 kW DC PV system for a total added cost of the building of a little over $2,300 plus the cost of that solar. So I'm not an expert on solar costs. I'll leave that up to Jonah to answer those questions, but this is a viable option to get this project to comply. We've also ran several different options based on compliance with the 2019 standards. So you'll see our baseline was the example we gave you in the previous slide. We've also ran an option with a heat pump. We've heat pump heating system, meaning that the air conditioning and heating is provided by that heat pump. We did an all electric route, which includes the heat pump for heating and cooling, as well as water heating. So you'll see the cost at the bottom. These are incremental costs above and beyond our baseline. As we move to the right, we've got a version with a battery storage. So 3.2 kW DC PV system with a 14 kWh battery adds a considerable amount of cost, but there could be some potential trade-offs there. Then we went to a 2x6 wall route. So you can see these options. The last option on the right, this is going to an unvented attic, and that's a strategy that some builders do to increase the performance of the building and reduce cooling loads. So all of those options are viable options for complying with our 2019 Energy Code in a real world scenario. All right, I want to move on to some very specifics about the PV and flexibility requirements. When I say flexibility, I'm talking about battery storage in particular. Some cases that might also mean pre-cooling for our buildings, but I'm really not going to go into that today. I want to focus in on some of these more common requirements. So PV systems are prescriptively required. I see the question up there is solar mandatory, or I assume that means prescriptively required. You'll if you notice, you go into the Energy Code, PV system requirements are under subchapter 8 in the standards, which is the prescriptive and performance area. If it were a mandatory requirement, it would be under subchapter 7, which is section 150.0. It's not. It's in the prescriptive requirement, which would lead you to believe that it's something that you could trade off and get rid of. Unfortunately, there are no provisions to get rid of solar by increasing energy efficiency. You can only reduce the amount of solar that is required by increasing efficiency. Now, there are exceptions. There's only one exception that eliminates the requirement. That is essentially, I don't have enough solar access, meaning the amount of solar insolation without shading minus the solar insulation with shading, or divided by the solar insulation with shading, is less than 70% over 80 contiguous square feet within the allowed range of azimuth and tilt. So that said, the only way to get rid of solar requirement is that you don't have enough access. If you have the solar access, then it's required. So the 2019 code got rid of the solar PV credit. If you're familiar with that, currently we can get some credit for using a PV system. It reduces the amount of energy efficiency we have to do by a slight amount. It's just a fixed rate credit. But that's been eliminated for 2019. The 2019 requirement is based on a prescriptive PV sizing equation. You'll find that equation. It's section 150.1 C14. You'll see the equations there. There's some adjustment factors. Those adjustment factors take into consideration the conditioned floor area of the dwelling, the number of dwellings, and the climate zone that that project is in, one of the 16 climate zones in California. Now, this applies to all low-rise residential new construction. If you're doing alterations or if you're doing additions, this does not apply to those situations, only when you're building a new dwelling. So if you're building a new accessory dwelling unit or a new single-family duplex, a townhouse, or a multifamily building 3 stories or less, this requirement does apply. So hopefully I answered both of Jeremy's questions there. I hope that was good news for you, Jeremy. But if not, we can talk about it during the Q&A section. So in addition to meeting those requirements, the system needs to meet the minimum qualification as specified in the Reference Joint Appendices, Chapter 11. So this is speaking about the orientation and tilt, speaking about shading, how much shading can occur and how do you calculate that shading, based on any obstructions that are outside of the building. You can't throw a bunch of dormers on your house and then say, well, I don't have enough room to put this. That's not a strategy for getting rid of the solar. There's no exception for that. If you have a bunch of trees or surrounding buildings that's blocking your solar access, then that can be considered, either to reduce the amount of PV required or potentially eliminate it outright. So the annual electric output of the PV system is greater than or equal to the dwelling's annual electric usage as determined by this equation. You'll see that equation 150.1c. We're not talking about big systems. We're talking about very, very small systems. As I mentioned earlier, we're only offsetting heating, cooling, water heating, and some other loads like lighting and some generic plug loads. If you have a house that has auxiliary buildings, pools, spas, all these other loads, that's above and beyond what's regulated under Title 24, Part 6. So that's above and beyond. Now, to give you an example of what those requirements look like, I ran some 2 different scenarios. One single-family home, 2,000 square feet in LA, which is climate zone 9. The equation came back with a PV system size of 2.62 kW. That's in BC. That's before the inverter reduction. But it's a pretty small system for a 2,000 square foot home. Most of you would be like, wow, we don't install systems that small. The Energy Code only regulates the minimum requirement. The utility is going to regulate the maximum size. So if you're planning to oversize anything greater than, I believe, 1.6 times the requirement, it's going to require or trigger the NEM rules, which you're going to have to negotiate with your utility and justify that system size. Now, for a multifamily building, I ran a scenario of it's a 30-unit, 21,000 square foot apartment building in Oakland, which is climate zone 3. You're looking at a little over 46, almost 47 kW DC. So again, we're not talking about large systems. We're talking about the minimum requirement to offset those electric energy that is regulated by Title 24, Part 6. Moving on to the flexibility, and specifically addressing battery storage. Battery storage is available only if you use the performance approach for compliance. If you're complying for new construction prescriptively, which I honestly don't know anybody who's done that. Currently, there's more flexibility in complying use of the performance approach. And I'm going to go into that in a little bit, talk about the trade-offs that are available. But it allows you potentially to use some of that flexibility credit towards reducing your total EDR. And I'm going to explain what the EDR or energy design rating is in a minute. And potentially, we'll get down to that bottom bullet there in a second, maybe trading off some of that efficiency EDR score. So there are minimum size requirements in order to even be considered for that flexibility credit is to have a minimum of a 5 kWh battery. So in addition to that, it's got to meet all the control requirements that are specified in the Reference Joint Appendices, Chapter 12 or JA 12. Flexibility for those PV system provides opportunities to reduce that. If you have limited space or limited solar access, by adding a 7.5 kWh battery, you can reduce that prescriptive sizing requirement by up to 25%. Or if you're trying to meet a particular jurisdiction reach code that may have a Cal Green Tier 1 or higher requirement, or some incentive program like the CAP or CMF&H programs that offer incentive money for building above code, you can use that. You can use the battery plus oversize that solar system to reduce your total EDR score or increase your total EDR margin. They call it a delta EDR to hit that target or reach that incentive program requirement. Lastly, with battery storage, I want to cover is this self-utilization credit. I spoke about this a little bit ago. That's utilizing the power you generate on that dwelling, storing it in a battery, and shifting the load to using that power after the sun goes down. So in that situation, you can trade off some of that energy generation and utilization against your efficiency. This is the only time that PV and battery can reduce your energy efficiency requirement. All other situations, you've got to meet the efficiency requirement. And I'm going to illustrate that here in our next slide here. So when somebody is using the performance approach, when I say that, they're using the software approach to justify their energy use, making sure that the efficiency EDR energy design rating is met, as well as that total EDR proposed total is met. So efficiency EDR includes energy use by our envelope. So walls, ceiling, floors, doors, windows, all those elements or features that are building shell, reducing heat gain, heat loss in our buildings, indoor air quality, HVAC, so heating, cooling, ventilation requirements, DHW, which is our domestic hot water or water heating requirements, unregulated loads. When I say unregulated, not regulated as part of the performance approach, but they are regulated. Lighting is mandatory. Appliances are regulated under our appliance efficiency standards, as well as some plug loads for our generic single-family house. So that incorporates all of our efficiency EDR requirements. On the right-hand side, we got our PV and flexibility EDR, which includes our PV systems. So a prescriptively sized PV system, or according to the choices made on the efficiency side, may affect that PV system size slightly. When I say that, what I mean is if I chose to go with a gas water heater and a gas heating system, well then my PV system sizing calculation using the performance approach would be slightly less than if I chose to do a heat pump for heating and a heat pump for water heating. So that does change slightly with the performance approach. In addition to that, it gives me the option of using those flexibility measures like battery storage or pre-cooling. Now, a couple of rules here. Efficiency may be used to reduce a PV system size. We saw that. If you don't have enough room for PV, or your client wants a really small PV system, great. Encourage more energy efficiency. We can reduce that. So the scale does slide to make that PV system smaller. In addition to that, you can use the exception with that battery to reduce our PV system size by 25%. Requires a 7.5 kWh battery. Now, going the other direction, you can use a 5 kWh battery to reduce the efficiency requirements. That's the self-utilization credit. Now, that's not just a trivial reduction. It's a pretty substantial reduction in a lot of different climate zones, potentially offsetting the electric or time-dependent value, or EDR value, of high-performance attics, high-performance walls, and that QII requirement. Remember, at the beginning of my presentation, I was talking about QII, quality installation. Installation is prescriptively required. And if you miss that, what could you do to offset the amount of energy efficiency? Well, a 5 kWh battery and self-utilization credit could potentially be the solution to that. So keep that in mind when you're talking to customers about overall efficiency of the building, what requirements, what kind of options do I have. That battery storage could be a real cost-effective solution to some of the more stringent requirements on the efficiency side. Now, what cannot happen is you cannot oversize the PV system and trade that off for efficiency. That's not allowed. There's no provisions in our code to do that. Now, you can oversize the system to trade off for your total EDR, but that has nothing to do with the efficiency side. It can't be traded off to reduce your envelope requirements, to reduce any efficiencies for HVAC systems, or trade off HERS verifications. That's not allowed. The only way to do that is through battery storage. Now, here's an illustration of what it takes to comply using the performance approach. So a project complies when, you'll see that down here at the bottom, the proposed efficiency EDR is equal to or less than the standard design efficiency EDR. So that's represented by the numbers over here on the left. And the total proposed EDR is less than or equal to the standard design total EDR. Both numbers need to comply. So we're talking about the ones in the red boxes. So the left-hand box is your efficiency EDR score. That needs to be less than the standard efficiency EDR score. In addition to that, after you apply your PV and flexibility to that subtracted, your total EDR standard design, which is represented on top, that number is larger than what your proposed is. So the proposed number needs to be less than or equal to what the standard is for total and for efficiency. So hopefully I haven't lost anybody or confused anybody. Let's see, we'll answer those questions in a little bit. Maybe we need to back up to some of these slides. So you might ask a question, is too much solar a bad thing? So if you think about solar, PV, electric generation, that occurs during daytime hours when potentially the demand may not be as high or be at its peak, and grid supplied electricity is plentiful. So you may have seen this graph before, but this graph is what I call, or many people call, the duck curve. The reason we call it a duck curve because it kind of looks like a duck. So what this is illustrating is our electricity demand in megawatts on a vertical scale. And on a horizontal scale is a 24-hour period during, most likely this is one of the hottest days in the month in a hotter climate zone. So back in 2013, we had a fairly low amount of PV production, meaning that our demand was met pretty much through distribution from our utility source. Over a period of time, which started to show up in 2015, we see a significant change in our PV generation. You can see that the belly of the duck start to be developed. As it gets lower, that means that the amount of generation compared to the demand, we've got an abundance of electricity on the grid. As we start approaching 2020, we're going to have a significant amount of electricity, which means the utility has to curtail that. They can't use it. There's not enough demand on the grid to use it, so they got to sell it. They got to do other means to curtail or reduce that amount of generation. Otherwise, they've got big problems on their hand. Now, as we progress on that hour scale, on the horizontal scale, you'll see a turning point where most likely the sun goes down, the generation stops, but our demand continues. We still have to cool our houses. We still have to turn lights on. We still have to do water heating and such. What happens is there's no longer a generation, an abundance of power on the grid. It turns to a demand or a demand event where utilities have to start ramping up or increasing the generation on their end to offset the load. That usually means that they're going to on-peak power plants using natural gas or other sources they're bringing in from outside. So what is going on here is if we just put solar on our rooftops, we're actually causing more problem than it's saving on a grid level. Now, what's being done about that right now is the utilities and the Public Utilities Commission are moving more towards dynamic time of use rates. What this is doing is it's encouraging the use of that flexibility and self-utilization. When I say that, I'm holding up a little air quote saying battery storage systems. So you'll notice during that June through September months on our image there, the top image, during our weekdays and weekends, what happens is the price of that energy between 4 p.m. and 9 p.m. is increased to 42 cents kilowatt hour, and then it drops back down to 23 cents. And again, these are more averages, not any specific rates by utility. So what happens is if we have a PV system and a battery system, we can bank that energy during those daylight hours, and at 4 p.m. have our batteries start discharging, and we're saving that 42 cents a kilowatt hour. So we're utilizing the energy we generated ourselves. So those rates vary based on the season and the time of day. Now, here's a good image of what's happening in reality. So their black line is their typical daily electric consumption. Now, this is on an individual dwelling basis. So you can see it fluctuates during the day. We got an increase in usage in the morning, it drops off to early afternoon, then it increases. Usually those are cooling loads, people are back in their houses, and then it peaks out around 3, 4 o'clock, maybe 5 o'clock in the afternoon, and then slowly tapers off into the evening. Well, the yellow area, that's our solar production. We get beyond our demand, then that's just excess. We're banking that, we're spinning our meter backwards. That's great. It's great for us individually, but bad for the grid. They can't curtail all that energy. If we store that energy on our battery systems and discharge that after the sun goes down, then we're saving that time of use rate. We're basically getting free power and pulling that from storage that we've already generated. So we'll save any questions till later on those. I see there's a lot of questions about PV systems. What I want to do is get into that all-electric pathway because I know I'm running out of time here. A couple of slides here. Where we're at currently with our 2016 Energy Code is the baseline energy source for compliance dependent on whether natural gas is available. A water heating is a single gas or propane tankless water heater. And if you use a heat pump water heater, there's an energy penalty for doing that. Our baseline for space heating is based on our choice. So if I choose to use a gas furnace, then my baseline is a gas furnace. If I choose to use a heat pump, then my baseline is a heat pump. So there's no penalty for heating, but there is a penalty for water heating. That's changing for the 2019 standards or Energy Code. Our source for compliance is no longer dependent on that availability of natural gas. It's the choice of the occupant, the builder, the developer, whomever is making that choice on water heating. So if you're choosing to use a heat pump water heater, go all electric, well then your baseline for your standard design efficiency is a heat pump water heater, meeting the minimum state and federal efficiency standards. There's no longer an energy penalty for doing that. So it also is going this all electric baseline encourages to utilize that electricity generated, meaning that you get a little bit larger PV system requirement, but it also gives the occupant builder the opportunity to take advantage of that PV system and bank some of that energy. You could store hot water, you could pre-cool your house, you could store that in a battery. So lots of options here in the near future. So where we're headed, so our energy code is taking those incremental steps or little baby steps towards a carbon neutral building, meaning that our buildings should not be producing any carbon, have the least impact overall. So since the inception of our energy code in Title 24 Part 6, it's all about reducing inefficient, unnecessary energy consumption and enhancing the outdoor environment as well as our indoor environment quality. Moving forward, we're looking at continuing to increase building efficiency cost effectively and reduce greenhouse gas emissions through renewable energy, and I'll add to that, and grid harmonization, making sure that that energy we're producing can be utilized on a statewide basis. All right, that was a lot of information. I know we have a lot of questions and answers, and David, I want to turn it over to you to go through some of the questions. I'm happy to answer anything that applies to my presentation, or Jonah, I'm sure you can answer other questions regarding the program.
Great, Brian. So much really good information, and I feel like we can just talk, or have you present and questions come in. There's just so much more to cover when talking about codes and compliance, but really great start. Thank you. And yeah, we do have a bunch of really good questions. As a reminder, if you haven't asked questions, you have them, go ahead and use that Q&A feature in your window there. I'm going to start with talking to Jonah about the Home Builders program. Brian, will give you a break and let you grab a sip of water or something. Jonah, for the Home Builders program, we got a couple questions. Let me see if I can summarize these into one or two. Basically, let's take a step back. Can you describe the BayWa Home Builders Solutions program? What do people get if they join?
Sure. Yeah, thanks, David, and really appreciate the presentation you just gave, Brian. Super informative. I learned a lot, and I hope the other folks on the call did as well. But specifically for a solar contractor, if you join the program and enter into our installer network, I think one of the most important things that any contractor want is access to projects. So through our efforts in marketing and connections with home builders, one of the things that will definitely be available to the solar contractor is a flow of home builder projects in California. With those projects, special pricing. So, BayWa already has super low pricing on good products, but for new construction projects, we're looking at ways to even improve that pricing. And one of the ways we do that is by co-proposing, I'll say, us and a solar contractor to a home builder. When we can team up, when we can bring the best of both companies to a project, we can really make an impact and hopefully win projects through home builders. And then there's another nuanced part of it, that not all home builders want a turnkey installation. Meaning they don't just want to buy the install and materials from a solar contractor. They may want to buy pieces of it. So for example, they want to buy a service or engineering or operations and maintenance or other bits and pieces of the delivery process without actually getting a turnkey installation from a solar contractor. And that allows them, better continuity of their projects, maybe to make more money for the builder. And it may just fit better with their existing process. So we're encouraging, and there's a bunch of folks our existing customers and folks that are wanting to be in the network that are perfectly happy with a service department to not supply a turnkey installation. So they'll do bits and pieces, maybe a pre-wire, maybe just entitlements, basically being flexible to allow the builder to get what they want and yet have the solar installer get a part of the project. So it's both a turnkey program as well as what I'll call ancillary services, the ability for a contractor to supply other than turnkey installations. So that's what a solar contractor gets, the flow of projects, special pricing, co-proposals, etc. Home builder, on the other side, of course, gets access to our installer network to that same pricing. And as part of just the standard BayWa approach, we have a web store that allows home builders and others to specify sort of standard systems and reorder based on previous designs. So that the web store, if anybody on the call has not been to it or is not using it, I highly encourage it. It's one of the best solar web stores I've seen online, and it tracks in with our inventory and pricing, and you can build your bill of materials right on it and order right there. So for the builder, especially doing repetitious track developments, I think it's a perfect solution. That's a little bit about the program, but are there other questions too?
Yeah, to tag along to that, is there an ideal size or kind of, I guess a specific question came in, the home builder builds about 10 new homes a year. Is our home builders program a fit for them?
Yeah, it could be. That's a fairly small, so that's probably a custom builder. So I don't know who you are, but it's probably a custom builder. And I'm generally building homes on the larger side, so more square footage and probably more expensive. And yes, perfectly suited to be part of the program. Depending on the size and volume, you may or may not want to buy direct from us. It may be better to buy through one of our installers and have them provide the turnkey project to you. So we're happy to talk, get your account set up, and work with you. We're not going to turn you away, but we may end up encouraging you to buy through an existing partner just for that continuity and for the turnkey approach that many of the smaller builders, and I'll call 10 homes a year a smaller builder, many of those guys are looking for that turnkey contractor, whereas larger builders, maybe doing 100 to 500 homes a year, we'll be looking for ways to eke out every little dollar of margin. So if that means they want to have their electrician do some of the pre-wire and then have the solar contractor come in later, we'll certainly work with a larger contractor to help facilitate that. So I think it fits for all different size contractors, but there's a bit of a sweet spot with the medium-sized regional builders. But we're not in the business of turning folks away.
Great. Okay. Thank you. In the last couple of minutes here, just get as many of these questions as we can. Brian, coming back to you, this question was asked a few different times. I believe you touched on it in your material, but just to close the loop on, what happens if the roof is too small to install the power required?
Yeah, and that's a great question. If you don't have enough space on your roof to install the requirement, there are provisions to either increase efficiency of the dwelling, the envelope requirements, mechanical system requirements, to reduce the amount of PV system required. Now, you're not restricted to putting that PV system on the roof. It can go into a ground mount system. It can go on an adjacent accessory building that is on the property. So the PV system requirements are only minimum sizing based on the actual condition floor of the house. So you have some flexibility there to place in that system. Now, if you're talking about shading, that's another issue. So if you don't have enough solar access, then you can reduce the PV system requirement on the available roof area that does have solar access, or potentially worst case scenario, you meet the exception for not installing solar at all. So lots of flexibility when it comes to the size and the amount of area of PV panel coverage on a roof.
Okay. And then the interesting question, is there a chance, and if so, what is the probability that the 2019 code requirements are delayed to a later start date?
Yeah, there's no chance. We saw the 2013 standards delayed 6 months. It was July 1, 2014. The 2016 standards went into effect on exactly January 1. 2019 standards will go into effect January 1. So nothing that I see as a roadblock to implementing our 2019 standards.
That's it. Okay, good.
Yeah.
Next question is on-site but off-roof solar okay for multifamily development, either with or without utilizing the community solar option and associated pre-approval? And the example is parking lot PV shade structures.
Yep, absolutely. Yeah. Basically, the code says anything within 250 feet of the building can be utilized for meeting the PV requirements. So the community-based solar is a animal in itself. So that requirement does take pre-approval by the Energy Commission that comes along with a lot of other requirements. Basically, you're creating your own power company, and they want to ensure that the benefit of that solar stays with that project for its lifetime.
Okay. And a couple questions just about the slides for your presentation, Brian. Yep, absolutely. We can make those available to you, as well as a recording of today's webinar.
Absolutely.
Next question, does dedicated cold storage equipment, for example, Ice Energy, ice-based cold storage AC system, count as pre-cooling for self-utilization flexibility?
Unfortunately, it does not. So when you're looking at ice storage for AC systems, that counts towards your efficiency, and there are benefits on the efficiency EDR side. The pre-cooling is a control that goes on your and attaches with your thermostat, basically not allowing you to use cooling after a certain time period. You can override that. You can always override that. It's kind of like a demand response program. But essentially, what this device is doing is it's pre-cooling your house up till 4 p.m. in the afternoon, and then during certain months, and then after that, not allowing that air conditioner to come on until after, I think, 8 p.m. So that's what the self-utilization pre-cooling works as. So.
Okay, and Brian, another one for you. Why is solar not listed in efficiency EDR?
Yeah, and that's a great question. A lot of people ask me what I do for a living, and I tell them, and they say, oh, I tell them efficiency expert in our energy code, and they say, oh, you mean you do solar? Like, no, I don't do solar. So efficiency is reducing the amount of energy used, and solar is generating electricity. They go hand in hand. They're like peanut butter and jelly, but we always look at efficiency first. We want to make the building as efficient as possible and then offset the energy use by solar. So, yeah, we can't commingle those, and our Energy Commission has done a great job of setting up a metric or a way of evaluating that separately, but also tying them together so that we can achieve our energy goals.
Okay. And I don't know if this is a question for Brian or Jonah, but really good question. How are home builders incorporating the price of the PV into the home? I mean, and this is a whole nother topic. How are PPA or leases used?
Sure, I'll take that. This is Jonah here. And indeed, that could be a whole nother webinar on how to finance solar with new construction, and I'd love to do that. But home builders are doing it in some of the same ways that retrofit market is happening. One is the builder simply buys the equipment or buys a turnkey install, adds that to the cost basis of the house, and marks it up and sells it on to the homeowner. However, more often, it's third-party ownership, PPAs and leases, where the home builder doesn't actually add any cost basis to the house. They simply sign the homeowner up for the lease or PPA for the next period of that product, probably 20 years. So it doesn't add to the mortgage, but it does still obviously cost the homeowner money. The builder is encouraged to do that because they would like to maximize other features in the home using up the mortgage dollars rather than the solar, partly because they can make more margin on it. But currently PPAs and third-party ownership are about 80% of the market. And so folks that are interested in competing with those third-party companies have their work cut out for them. Any other creative financing solutions that allow builders to keep the cost off the mortgage will be really enticing for folks to use.
Okay, and one last tag-along question to that, Jonah. Who gets the ITC on a new home build? How does that get passed on to the homeowner?
Well, it's whoever owns the system. So in a third-party ownership model, of course, that company gets it, whether it's SunPower or Vivint or Tesla or somebody else. If the homeowner owns the system outright, either because they put it on the mortgage or got an off-mortgage loan, then they would get to take the tax credit. But it goes to the owner of the system, and there is a way to transfer that ownership, but that gets a little more complicated. Yeah,
boy, it's a lot of good questions on the financing ownership. Yeah, we can certainly have a whole separate webinar about that. Keep an eye open for that. Well, with that, we are at the top of the hour, and I do want to respect everyone's time. Thank you. We really, really appreciate you joining us. We know this is your busy time of year, so you taking this hour means a lot. Hopefully you got a lot of good information. Any questions that we weren't able to answer, or as often happens, as soon as you hang up, the question comes to mind, we will send you our contact information to go ahead and ask. But really great information. Jonah, Brian, thank you. Really appreciate your information as well.
Yeah, it's my pleasure. I'm glad I could participate in this. And like David said, they'll send out my contact information. If you have any questions about our energy code, I'm happy to respond and give you as much information as I know.
That's great. Thank you, Brian. Appreciate it.
Wonderful. Gentlemen, folks, thanks again. You have a fantastic day. We'll talk with you soon. Bye now.
Thanks again.
Bye all.